In this example, we're going to again go through the steps to find key features for graphing quadratic functions by hand in a different example. And to start, we are going to have the axis of symmetry first. And to get the axis of symmetry, we have used this formula for a while now, and we would get x is equal to negative b over 2a, which ends up being negative b being 4 over 2 times a. Make sure you carry the negative sign in a. It should be negative 1 in this case. And simplifying everything will give us x is equal to positive 2. And that's the axis of symmetry, x equals 2. Using this, we can find where the y-coordinate is for our vertex, because we know axis of symmetry goes through the vertex as a vertical line. And with this, we get h of 2 is equal to negative 2 squared plus 4 times 2, then minus 4. And if we look at it, we have negative 4 plus 8, which would be positive 4, minus 4, which is 0. So we get the vertex is 2, 0 over here. And I'm going to write down 2, 0 is the vertex. That's the first key point we need to get. And then for part B, we want to find what's the y-intercept and its mirror image. And for the y-intercept, by now we have looked at the y-intercept as where it intersects with the x-axis, so we are looking for h of 0, because on the y-axis we would have the x value being 0. And h of 0 equals negative 4. If we do the calculation, it should only leave us with a constant term. And that tells me 0, negative 4 is going to be the y-intercept. And then to find its mirror image, here I get 0, negative 4, in this case being the y-intercept, and the axis of symmetry is x equals 2, so to find its mirror image should be somewhere here. This is just a rough sketch to give you an idea as to where the points are placed in relation to the axis. So if the other point is equal distance away from the axis of symmetry, that means we can just use 2 times 2 to be in the x-coordinate for the vertex or the axis of symmetry. So we can have 2 times 2, which is 4, comma, negative 4, because these two are equal distance and at the same height. And these are the 2 points we get. For negative 4 is a mirror point. And next, we want to move on to the x-intercept. For x-intercept, we are going to use a quadratic formula to let h of x be equal to 0. So we get x equals negative b plus minus square root of b squared minus 4ac all over 2a. And we can directly use it because we want h of x to be equal to 0. And therefore, if I plug things in, we would get negative b would be negative 4 plus minus square root of b squared, which is 4 squared, minus 4 times a, so that's negative 1, times c, which is negative 4. And this is all over 2a, so you get 2 times negative 1 as a result if we plug everything in. And here, if we simplify things, we would get negative 4, and under the under the radical, we would get 16, and 4 squared gives us 16, but also the second part will be 4 times negative 1 times negative 4, which would also be equal to 16, right? Because if we don't include the first negative sign, this would also be 16. So as a result, we get 16 minus 16 under the radical, which means we have square root of 0, or just 0 overall. So on top, all we have left is negative 4 plus or minus 0, which doesn't change value, all over on the bottom, negative 2. And this should be equal to positive 2 over here. And I hope this is not particularly surprising, because if you look at the point now we have for the x-intercept, it's a point 2, 0 over here, which we said was a vertex. And if you think about it that way, the vertex is a point that's on the axis of symmetry because of the fact that the x-intercept is on the axis of symmetry. It doesn't have a mirror image anymore, because before, when we think about the two x-intercepts, they're always going to be mirror image of each other across the axis of symmetry. But here we have a point that's already on the axis, so we can't possibly find its mirror image anymore. And therefore we only have one x-intercept, and in particular that x-intercept is just the vertex in our case. So this doesn't give us any new point over here. This is essentially a repeated point for the x-intercept. And with that information, we want to think about what happens next to our graphing process. So first thing, we just want to carry on to find another pair of points that will be helpful first, just like we did. And for the next part, I'm going to find any random h value that works out nicely for us. And just to make my calculation simple, I'm going to choose x equals 1 in this case. So we can find h of 1. And that gives me negative 1 squared plus 4 times 1 minus 4. And it works out nicely because plus 4 minus 4 already cancel each other out, and I'm left with negative 1. Be careful that this is a negative 1. The negative signs don't cancel each other out, because that negative sign is a sign for this term. And that tells me the point I have will be 1, negative 1. And if we think about where 1, negative 1's mirror image is, we can again use this little scratch work that I did over here. If I had 1, negative 1, it'll be somewhere here, right? This is not to the scale, but let's say 1, negative 1 is here. If I want to find its mirror image, it needs to be equal distance away from the axis of symmetry. Here, the distance should be 1 on either side, because the difference between x-coordinate of my point and axis is 1. And therefore, this point should have an x-coordinate of 3, because 2 plus 1 will be 3. Height will be the same, so 3, negative 1 will be what I get over here. And therefore, my mirror image is 3, negative 1. Now looking at all the points, we want to check to make sure we have at least 5 points so we can get a somewhat nice graph. And if we count it, we have 1, 2, 3, 4, 5 points that are now repeated. With that information, we can go ahead and scale things. And just looking at the amount of space I have, I think I can go for every 2 boxes being 1 over here. And therefore, it would look like 1, 2, 3, 4, like this. And I'm going to use the same scale on both x and y axes. Lastly, on the negative side of x-axis, we have negative 2 and negative 4. Now plotting all the points, I have the vertex being 2, 0. That should be my turning point. And then I have y-intercept as 0, negative 4, which is down here. And then I have 4, negative 4 being its mirror image. Then I have 2, 0 again, so I can't use that as a separate point. So right now I have 2 points, and I need 2 more points. I have 3 points right now, and I need 2 more points. Then we have 1, negative 1, which would be over here. And then 3, negative 1 will be over here. And as we connect all the points, we would get this graph. Again, I tried my best to make it smooth looking, but this is again a downward opening parabola graph for h of x, which can be extended on both directions, so we use arrows to show that.